record. You recording? You are.
What's going on there?
So we figured out what percentage of adults are dull normal last time around. Now there were a few parameters we had to know. IQ scores. IQ scores have an average of, do you remember? Remember what the average IQ score is? By definition? 100. Why was it 100? Do you remember why? 100 points.
Because it's right in the middle.
Why is it right in the middle? I love that answer, Michael. It is on average. It's bell-shaped. You got it, friend. It's bell-shaped, and it's 100. And actually, the reason why it's 100 is not answerable by something we learned in this class, except for the little trivia thing that I told you about. What does IQ stand for?
Oh, it's your intellectual age over your real age?
Perfect, Kelsey, perfect. What it is, they take your mental age, your intellectual age, which they get from a test, and they divide that by your chronological age, your real age.
Is that
And that-
test very accurate?
You have to know what intelligence is to know if it's accurate, and that's not a
And
question
that's
I'm
not
willing to
really
answer
defined.
because I have no idea what intelligence actually is. All I know is this test averages 100 middle of the bell curve because of exactly what Kelsey said. Your mental age over your chronological age, if they match exactly, then it's 1 to 1 times 100 as a percentage is 100. Exactly. Remember what the plus or minus on that was? How many points? It was 15 points. And I'm putting points in parentheses because very often that is not used. It's just, oh, I have an IQ of 100 or 110 or 95 or whatever it is. It's just that's all it is. So now knowing that and knowing that it's a bell curve, like Michael said, we get quite a bit for free. We get quite a bit for free. For example, if I add and subtract 15 points, I'm going to get 115 up top and I guess 85 down below. And you know something about how many, or at least the percentage of those who scored between 85 and 115 on an IQ test.
68.
Good! Roughly 2/3, about 68% of them. Right? What percent score above 115? What percent score above 115? Percent. Now, not number, because you have to apply that to a population. So what percentage? Do a little teeny tiny bit of arithmetic here.
17 or?
Oh, tell me why, Tabitha. I love it. Tell me why.
I'm getting excited. I'm happy.
Oh my gosh, 32%,
Mhm.
just split it in half.
Mhm. So this is 68%, or 2/3, whatever you want to look at it, 68%, which means the other 32 has to be here and here. And contrary to how I drew the curve, it's perfectly symmetrical. So half of that has to be here and half of it has to be here. Perfect. So 16% are above 115. Love it. That's great. And we get the other usuals as well. We get the 2 standard deviations. We go up to 130, down to let's see, that would be 70. Now we're getting into that moron idiot range. And I don't know what the old range was, like gifted, genius. They were equally un-PC, but those aren't the ones that make us. It's so funny. I mentioned idiot in class, they whole class like, blah, 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 blah. It's amazing to me that a word that started life as a serious marker on a scale has become part of our kind of condescending vernacular. It's kind of wild, actually, to think about that. Anyway, you know what percentage of people have IQs between 70 and 130, don't you? Exactly. So I started with this because somebody had told me earlier, right before class started on at 10:15 today. Recently, there's a group called Mensa, who you may have heard of before, and I forget what it stands for, if it stands for anything. But it's the High IQ Society, is what they
it's like
determine
it's a bunch
themselves.
of geniuses, basically.
Well, it's a High IQ Society.
Well, yeah.
I don't know what that means, other than the fact that they have high IQs. And here's the requirements for getting in. The requirements for getting in, okay, to admit to Mensa, all right, you have to be in the top 2% of IQ scores.
So if the IQ scores go up, the harder
So this is like seriously the smartest.
Now, hold that. Athena, can we come back to that question?
Okay.
I want to make your question. Athena asked a very good question. She asked, say it again.
As the IQ scores go up, because there's more education happening than there used to be, the harder it is to get in.
Okay, the education bit is arguable, but I want to come back to the idea about the IQ score going up and the difficulty of attaining them. Can we come back to that if that's okay?
Yep.
Fantastic. So the question I have is, okay, you've got to be in the top 2% of IQ. And the reason we bring this up is because I was just told by one of the students that a 3-year-old child was just admitted to Mensa.
Right.
And I said, well, that makes perfect sense. There should be more than one. And they were like, what? What do you mean more than one? I was like, I'm surprised more 3-year-old children aren't being admitted to Mensa.
For their age.
So what I want to come back to is why it seems surprising. Some of you are like, yeah, I totally buy that after our discussion of last Wednesday, but you may have forgotten our discussion last Wednesday. So the first question I have is this. Yeah, that's the requirements for Mensa, right? But what IQ score is that? No, it doesn't. It depends on this curve. It's above 130, isn't it? It's above. Why do you say that, Kelsey? You're 100% correct.
Because it's 5% less on 30 and
95% goes from here to here. That means there's 2.5 in this tail and 2.5 in that tail. So clearly, whatever the IQ score is that chops off that top 2% is a little bit to the right of 30. And I don't know how little bit is. That's our job today, is to figure out what that little bit is. So basically, I want to know, that's a question mark, pretend it was a question mark, I read it on this side. Okay, that's better. I want to know what that IQ score is that puts 2% right there in that tail. It's above 130, as Kelsey just said, 100% correct, 100% correct. But what is it to the nearest whole percentage point? So let me ask you a question. Well, we could if the damn thing was discrete, but it's not.
No, I meant the other one.
You meant the other one, and the other one is the one I want to use for sure. But can we take a step backwards though, Athena? Before I love what you say, and it's 100% correct. What kind of problem is it? Is it forwards or is it backwards?
Forward.
backwards.
Backwards.
You know what you
Essentially, we have the forward side of the class and the backward side of the class.
Backwards, because I know I want 2%, so I have to
Yeah.
98% away.
That is
Yeah.
definition of a backwards problem. I've given you a percentage. You need to find the number on the scale down here. Now remember, these names, forward and backward, I made them up. They're arbitrary. They're arbitrary. I don't even know why I called them that. I mean, I think because the first problem we did that one day, I thought of it was a forwards problem. So let's call that forwards. But the difference is, what do you have and what are you looking for? The dull normal problem was a forwards problem because I said, what percent of people are dull normal? That is, they have an IQ between whatever and whatever. So you actually knew the IQ scores and you were going for the percentage. Here you know the percentage and you're going for the IQ score. Does that make sense? See that distinction? So if you start with the percentage, it's always going to be a backwards problem. So the question is, how do we attack this? How do we attack this? Athena had an awesome idea that I like an awful lot. She said, we're going to go to the normal. She wants to use the normal. I'm totally in agreement with her. The problem is that's not the normal. That's just normal. Now, I say JUF or general normal. If you remember that horrendous vomit-inducing graphic we had up momentarily ago, it had lots of distributions. One of them was just called normal, which I'm calling JUF or general normal, and it drew a line to the standard normal distribution, which is still normal. What makes the normal standard normal? What does that bell curve look like? The standard normal curve, the one that I gave you the program for. What number's in the middle there? Yes. Yes. Zero's in the middle there. Don't forget about him. Well, actually, it's okay if you forget about him. We're going to revisit him today. That's the whole point. We're visiting.
Figuring out that.
Oh, don't you worry. We're going to refigure it. A week is a long time to talk about this stuff. I know, so we have to go visit it again. What's the standard deviation of the standard normal curve?
1.
Exactly. So up and down one standard deviation corresponds to these guys here. So a -1 on that curve corresponds to an 85 on this curve. A +1 on that curve corresponds to a 150 on this curve. Some of you are sitting there going, Rule, why don't you just give us a program that you can put that curve into?
Did you?
I didn't.
Oh.
Why didn't I?
Uh-oh.
How many of these are there? Now, not for IQ, but in general. Infinitely many, right? Think of every possible average value for a continuous random variable and its possible standard deviations. The combinations, if you will, the permutations are endless. But there's only one standard normal curve. So if all you learn how to do is to convert back and forth between them, you're golden. You've got a program that takes care of this one. And you can do the conversions back and forth between this one and this one. Boom, you're done. That's all you need. If you don't buy that, don't worry. We'll get to it in about 2 minutes. Okay, so we can also go down to -2 and +2, right? -2 and +2. Do you see what they correspond to over here? Hell yeah. Negative 2 corresponds to 70. Notice it's 2 standard deviations down. 2 15s is 30. 30 down from 100 is 70. Fair enough. 2 standard deviations up would be 30 up from 100, which would be 130. So what Kelsey said, again, rings true. She said we've got to be more than 2 standard deviations above. Well, you didn't say it exactly like that, but that's what you were basically saying though, right, Kelsey? Somewhere over here is a z-score that puts 2% in that tail. Somewhere up there is a z-score that puts 2% in the tail. It's our job to find it. And then once we have that, we're going to use that to find the IQ score via the transformation. One of those arrows that you saw on that little diagram up there. Cool? So Athena, I think we're now ready
Okay.
for your hint. Athena's hint was, let's use the normal. And I was like, oh yeah, let's use the normal. But we couldn't use it at this point. We couldn't use it at this point. If you tried to use it at this point, the number that you got out wouldn't make any sense with this curve. But it'll make perfect sense with this curve, won't it? Let's take a look. Let's take a look. Let's make sure we can see this too. Because we're going to have to kick this up to see the screen. Pull the screen down. And the normal part, the program part, is a very small component of the overall problem. Let's fire this up. All right, Mr. Normal, here we go. Beautiful. On, program, normal. Definitely backwards. Have a percentage going for a z-score. Your choice on area. You can shade it either way. It's just a matter of putting the correct area in. And here's exactly, if 2% is shaded to the right, what percent is shaded to the left? The other 98. Your call. Your call, essentially. Basically, this is the 98th percentile, isn't it? 2% above is 98% below. So your call. What did you put in right, since that's what we drew? We did draw to the right. So now you're going to put in 0.02. If you put it to the left, you put in 0.98. It's the same z-score. The same z-score does that. Is that fair? Do you guys buy that logic? Okay, I'm just going by what we actually put. Make sure you have 0.02, not 0.2. It's only different by the power of 10. Yes?
Did you do left or right?
I did right just because that's what I shaded on the actual board.
I did left.
That's okay. Put in 0.98. Check this out. I love this. Actually, Athena, you did left?
Yeah.
Good. Perfect. I get z equals 2.05. Athena, may I borrow your TI? If you do right, has to happen, right? Has to happen. The same z-score that puts 2% in this part puts 98% in that part. So it doesn't matter. This is the beauty of it. Thank you, my friend.
That's because you made the program.
No, that's because it's mathematics. That's because it's... Give me that crap. It's because it sums to 100%. It has to be that. It's because I made the program. I swear to God. So there we go. I know, dude, I know. So there you go. So Kelsey, we now have a quantified to 2 decimal places at precision of your claim. It's more than 130. It is. It's 0.05 above a z-score, which might not seem significant, and that's not up to us to decide. We decide the significance in Math 244, those of you joining that journey, which is fantastic. So we got our z-score. Fantastic, fantastic. Let's mute this. That's all you need the normal for, was to get that value. That's all. And that's what, back in the day, we used tables of values to find. Now it's the normal state takes its place. It's totally fine. So we now know that this z-score is 2.05, which is great, except for the fact that it still doesn't answer the question, which was what?
What's the number that is?
What is the number attached to that? Right, that doesn't tell us what the IQ score actually is. All it tells us is where it is. Where it is it's 2.05 standard deviations above average. Tabitha?
Well, since we know that there's the 0.05 that is above the 2, can we find the percentage of the 0.05 that is the 2 and then multiply by the 1?
Perfect, my friend. It's exactly correct. It's exactly correct. Since we already know what a standard deviation is in the curve. It's 15 points. So we know we're going above average. So we're starting with 100. Let's just quantify this a little bit here. Okay, to put it on this curve. We know we're 2.05 standard deviations above average. So we know we're starting at the 100, which is average. And we're above it by 2.05 standard deviations. So all you got to do is take the 2.05 and multiply it by the 15, which is the standard deviation. So Tabitha, this is essentially what you're saying, but I'm doing it all in one step. The 2 out front, the 2 times 15 gives you the 30. So there's the 130. But the 0.05, as she pointed out, times 15 gives you the extra little bit that pops you up, which this is 0.75. So I'm thinking this is going to be 130.75, which, call it 131, just to round it off to the nearest whole percentage point. That, my friends, is the IQ score you'd have to get to test into Mensa. And Mensa doesn't have like an age category. It just says this is, if you have to score in the top 2% of standardized tests. Ooh, I should drop that down.
So is it, once you're in Mensa, are you in? Because how do all the really old people keep...
I don't know. It's a great question. I don't know the answer to. Yes. I love that question. What if you're 120? That means you have to test as an IQ of like a 150-year-old person. I have no idea. I have a 160-year-old person, I guess. I don't know the answer to that question. But I do have a rationale. Does everybody follow the logic on this? You see what we had to do? We had to go dance back and forth between the 2 curves. I want to come back to that because we did use an equation without using an equation there. You may have recognized the move we did. Do you see now, maybe you don't, why I don't think it would be all that hard for a 3-year-old to get into Mensa? Check this out. The IQ separating Mensa from non-Mensa is 131 points, which is roughly 30%, I don't know how I'm going to say this correctly, it's 30% more mental age than chronological age. That sounds stupid, but that's what it means, right? Because IQ, if you think of it, IQ is your mental age over your chronological age. That's the definition of what IQ is. Whatever IQ is actually measuring, I don't know, but that's what it is. So, in other words, you have to have an IQ of 130, which as a decimal is 1.3, right?
Yeah.
So this kid that tested into Mensa was 3 years old, chronologically.
Just 4.
So, exactly. The kid is 4. If you multiply 3 times 1.3, that's essentially 4, which means the 3-year-old would have to be as quote-unquote intelligent as a 4-year-old. Think about this. How many times have you met a young child who seems older than they are? Boom, they're in Mensa. I mean, that's the definition of what we just saw. It's not that big of a deal, and this goes back, it's kind of the converse of what Kelsey asked. It's not that big of a deal for a young child to test high on an intelligence if they're precocious.
Well, the thing is that, development in young people is super varied.
Super varied,
depending
Raphael.
on adults.
Super varied.
Yeah.
But how many people in this room have met a very young child who seems older than they are? Look at that. Every hand that goes up potentially has this ability to have an extraordinarily high. Now, of course, I'm associating the word intelligence with seems older than they actually are. That might not be a fair correlation, but I mean, I think it's easily explainable why a 3-year-old made it into Mensa. My surprise is that there aren't more. And the only surprise there is that their parents aren't putting them through the IQ test, which good for them. Let them go outside and play with frogs and stuff. Fair? Now, did you guys catch the formula that you actually used in this problem? Because you did. We had a couple formulas on the board last time. I told you I've been hiding formulas from you intentionally because I want you to not memorize formulas. And any formula you need, I will put on the board for you if you need them during an exam. Tabitha?
Mu plus X population deviation.
Yes. So, we had 2. This was the backwards version. This was the backwards version. So did you notice what we did right here? We took the average mu plus the z-score times the standard deviation of the population. Well, that's exactly what that was. Mu plus the z-score times the standard deviation of the population gives you, well, I usually call that x for a raw score. So basically that puts you back on this curve. This puts you on this curve, basically. And that's why I call it a backwards problem, because a backwards problem aims to get you back onto that curve. It aims to get you back onto that curve. That's backwards. Forwards, which we'll see one of these in a second. We'll see one of these in a second-ish. I use the word second kind of loosely. Forwards is the inverse of that. That's where you have z on one side by itself. So if you were to solve this for z, it would look like this. X minus mu over sigma. That one's less obvious. I forced you guys to derive it last class. You didn't like me very much after that. Yeah, I kind of walked you through, okay, so how many standard deviations down is it? Because what it does is, it looks at this curve, and it normalizes that curve down to that curve, creating a standard normal situation that you can then analyze percentage-wise with your program. And I made you guys do this with the IQ scores. I made you use that 15 and 5 and 1/3 and 2/3 and 4/3, and you were getting pissed. That's okay. That's okay. That's why we have this. That's why I say these are actually nice formulas to become familiar with, because they actually save us time. Most formulas tend to be kind of confusing because you don't really know the ins and outs of why they work. I forced you to develop this one, and you guys had an intuitive feel for this one already based on what you saw. So they're actually very, 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 very user-friendly formulas. Plus, there's not much mathematics. I mean, multiplication, addition, subtraction, and division. So this one tends to... What's the matter, Raphael? I'm sorry. Yeah, this one's a little bit more user-friendly because it has adding and multiplying, which are a little bit nicer because you can screw up order and still get the same answer. You can't really screw up order here and get the same answer. You get wrong answers. If you mix and match the x and the mu, you get a negative value, which doesn't seem like that big of a deal, except it goes from being the 2nd percentile to the 98th percentile, and you go from being an idiot to being a genius. Like unquantifiably. You're like, oh, I thought he was an idiot. No, he's actually a genius. You know, that doesn't make any sense. I mean, you can't just flip-flop around the curve. That's why don't memorize the formulas. I'll have them on the board for you, please. Just use them. Know how to use them. Cool? Make sense? Let's take 5. I got a couple other examples to make sure we firm this up, we understand it, and then we're going to get into some parameter